All right, so here we have a golf ball gets hit by a club. After it gets hit, we know its speed. So since we know its mass and its speed, we'll know it's what? Well, two things, but since we're asking about work, what's pertinent mass and speed? Right, kinetic energy. All right, assuming that the force of the golf club is parallel, and then we have a contact amount of distance, right? The amount of distance through which it moves while it's in contact. Since we have a change in kinetic energy and we have a contact time, a distance, again, the distance over which that work is done, we then can figure out what? Well, we're figuring out work done based on the change in kinetic energy. But once we know work is defined as we got the change in kinetic energy as work, okay? And now we have a distance over which that work is done, so we'll be able to figure out the force, exactly, the average force. Okay? So again, what do we know? We know that work is equal to delta kinetic energy, and we know that work is equal to force times distance, or, FD cosine theta, but it says it's parallel. Okay? So it's sort of a two-equation strategy kind of thing. We're solving for work based on this right here, and then we're going to solve for force based on the fact that those two statements are equal. Okay? So let's start with how we're going to figure out the kinetic energy. All right, so we know that change in kinetic energy is equal to Ke final minus Ke initial. All right, but I assume that when you're playing golf, you just sort of tee it up. I mean, it would be an interesting, different golf game if the ball was moving when we hit it, but let's just stick to the standard golf where we put it on a tee. All right, so taking this equation right here, we're going to say that, coming down here, kinetic energy is going to be equal to 1/2 mv squared, right? So that's what the work is going to be equal to. All right, so how much work is done by the club? 1/2 mv squared. All right, so work is equal to 1/2. The mass is 0.045 kilograms, 45 grams, times v, which was 41 meters per second. Calculator brigade out there. So it's at 37.8 kilogram meters squared per second squared. Sounds like joules to me. All right, so that's the answer to part A. All right, now moving on to part B then. We have, what's the force? We also know that work is equal to FD cosine theta, but we're told, assuming that they are parallel, that cosine theta is going to be equal to 1. So we can just not ignore it, but we don't have to worry about it. All right, so that means that work, which we've already established, was delta Ke is equal to force times distance. So force is going to be equal to the change in kinetic energy over distance. All right, we had that the change in kinetic energy was 37.8 joules divided by the distance, 0.010 meters. Okay, some serious, that's 3 sig figs, isn't it? All right. So that gives us, that means we're multiplying by 100, right? Dividing by 1/100. So force is going to be equal to 3780 joules divided by meters. Dimensional analysis. Joules is kilogram meters squared per second squared divided by meters. Gives us kilogram meters per second squared. That's newtons. All right. Box it. And that's the answer to B.